Okay, reviewing the class notes briefly. We have two ramps at angles alpha and beta with respect to the horizontal, angles of inclination alpha and beta, masses M1 and M2. We have coefficients of friction, static friction mu sub S1 and kinetic friction mu sub S2 on this incline. And something on my screen here, okay. And coefficients mu sub S2 and mu sub K2 on this incline. So we ask, what are the forces? We want to analyze this system. We want to analyze the motion of the system. If the system's in motion, does it come to rest? Does it accelerate? Does it change direction? If it's stationary and released, will it move, and in what direction? So we want to list the forces acting on this system. Now, what are the forces? Well, we know we have a gravitational force, and I'll write that as negative mgj, negative m2gj, and I've got an unfortunate arrow in here. The g doesn't have an arrow over it. Okay, negative m1gj minus m2gj. Okay. The normal forces, we know that by virtue of the fact that at least part of the gravitational force is pushing this into the incline will exert an equal and opposite force in this direction. And similarly here, we have a normal force acting on M2. So we have Fn1 and Fn2, excuse me, the normal forces. And there are also frictional forces. Unless these coefficients of friction are all zero, we expect that there will be some sort of frictional forces. There will also be tension forces. You have tension in this spring. Now, if you regard the system as a whole, that tension force is internal to the system. If, however, you regard M1 and M2 as separate objects, then you have a tension force on M1 in this direction, tension force on M2 in this direction. So if we do free body diagrams for the two masses, we see that we have the weight force, frictional force, and we don't know what the direction of the frictional force is because we don't know in what direction the system might be moving, and we don't know which mass and incline gives us the greater effect. In other words, does this mass tend to pull down its incline with more force than this mass pulls down its incline, more or less? We don't know any of that, so we don't know what the direction of the frictional force might be. So I just arbitrarily draw a frictional force in this direction of the incline. Now this would be the diagram for mass M2. We have the weight, which of course is M2g. We resolve that weight into components in the x and y directions using an xy coordinate system that's parallel to the incline, the x-axis being parallel to the incline, the y-axis being perpendicular. Okay, so we have this free body diagram for this mass, and we have a similar free body diagram for the other mass. Again, the friction is drawn in an arbitrary direction, and that's the direction of the friction is a decision that we have to make, or we have to make a decision about what the direction of the frictional force is when we have other information about the system, when we have more specific information. These free body diagrams, though, would summarize all the would represent all the forces acting on this system. Now we're going to go on in a second, probably in a second clip, and see how this goes together to give us the behavior of the overall system.